Let's talk about something you use every day but rarely notice: tires. They're on cars, buses, planes, and trucks, moving everything and everyone. Without tires, our world would grind to a halt. They're the unsung heroes of modern life, connecting us all. So, buckle up, let's discover how these marvels keep our world moving. So, you think a tire is just a tire? Wrong. That's like saying all cheese is the same. A cheap, rubbery slice of plastic cheese is nothing like a fine, crumbly Stilton. And it's the same with tires. The ones on your family hatchback are designed for a completely different life than the ones on a massive articulated lorry thundering down the M1. Your car tire needs to be quiet, comfortable, and good in the rain. It needs to last for tens of thousands of miles while providing a smooth ride so your children don't complain in the back. It's a marvel of compromise. A truck tire, on the other hand, is a different beast altogether. It doesn't care much for comfort. Its main job is to handle immense weight day in and day out for hundreds of thousands of miles. It has to be incredibly tough to resist punctures from road debris and to dissipate the enormous heat that builds up on long journeys. The rubber compounds are harder, the sidewalls are reinforced with thick steel belts, and the tread pattern is designed for maximum durability, not for silently cruising through a leafy suburb. It's a workhorse, built for pure, unadulterated strength and endurance. Then we enter the world of giants. The tires fitted to heavy construction and mining equipment are on another level entirely. These are not just tires, they are monumental pieces of engineering that can stand taller than a person and weigh several tons. A tire for a Caterpillar. 797F mining truck, for example, is nearly 13 feet tall. It has to support the weight of the truck plus up to 400 tons of rock and earth. You can't just pop down to your local Quick Fit for one of these. They are built to survive the harshest environments on Earth. The secret to these differences lies in their construction, which we will delve into later. The blend of natural and synthetic rubber, the number and type of fabric and steel belts, the depth and design of the tread, every single element is meticulously engineered. A racing tire is designed to be sticky for grip, but wears out in minutes. A winter tire has special compounds that stay soft in the cold, and a tread that bites into snow. A tractor tire has huge V-shaped lugs to find grip in thick mud. They are all black and round, but that's where the similarity ends. Now, tires are useless on their own. They need to be attached to something. And often that something is enormous, powerful, and designed to do jobs that would make a superhero break a sweat. I'm talking about the big boys of the mechanical world. Excavators, bulldozers, and dump trucks. These are the machines that build our world. They dig the foundations for our homes, lay the roads we drive on, and mine the materials that make everything from our phones to our cars. They are the steel titans that terraform the planet to our will. When you see a huge skyscraper rising from the ground, it didn't just appear there. First, a fleet of machines had to arrive and change the very landscape. Giant excavators with massive buckets scooped out thousands of tons of earth, loading it into a convoy of dump trucks. Then, bulldozers, the undisputed kings of pushing things around, arrived to level the ground with brutal efficiency. These machines are the embodiment of power. They are driven by massive diesel engines that produce biblical amounts of torque, allowing them to shift incredible weights with what looks like effortless ease. And how do these behemoths move? This is where our story gets even more interesting. Some, like the giant mining trucks, use the colossal tires we just talked about, but many others use a different and frankly more brilliant solution: tracks. Look at a bulldozer or a tank. Instead of wheels, they have a continuous belt of interlocking metal plates. This is genius because it spreads the machine's immense weight over a much larger area. A wheel puts all the weight onto a tiny patch of ground, but a track creates a huge footprint. This means that a heavy, tracked machine won't just sink into soft ground like mud, sand, or snow. It floats over the top. This gives it the ability to go to places where wheeled vehicles would be utterly, hopelessly stuck. It also provides phenomenal grip, allowing a bulldozer to push with immense force without its wheels just spinning uselessly. The choice between wheels and tracks is a fundamental one in the world of heavy machinery, and it all comes down to one thing: the job the machine was built to do. We will explore this epic battle, wheels versus tracks, in more detail. It's more exciting than you think. The car tire, black, round, and often ignored until trouble strikes, but it's a masterpiece, gripping roads in sun and rain, staying quiet and comfortable and lasting for thousands of miles. Next time you glance at your tires, give them a nod of respect. They're doing far more than you think. The truck tire, the workhorse of the motorway. Built for endurance, it carries massive loads, resists punishment, and keeps going mile after mile. With thick sidewalls, deep tread, and steel belts, it's engineered for strength and longevity. Many are retreaded, lasting for hundreds of thousands of miles, true unsung giants of the road. Forget everything you think you know about tires. We are now entering the land of the giants. The tires fitted to the colossal machines used in mining, quarrying, and massive construction projects are on a completely different scale to anything else on Earth. These are not tires you can load into the back of a van, you need a crane to even lift one. A tire for a giant dump truck like the Caterpillar 797 can be over 4 meters tall, weigh more than 5 tons, and cost more than a brand new luxury car. They are, without a doubt, some of the most extreme pieces of engineering on the planet. Their job is almost comically difficult. They have to carry the weight of a truck that is already as heavy as a small house, plus up to 400 tons of rock or ore. That's a total weight equivalent to a herd of elephants. They do this not on a smooth motorway, but on rough, unpaved haul roads littered with sharp rocks, gravel, and other debris that would shred a normal tire in seconds. Every single rotation of the wheel is a battle against immense weight, extreme abrasion, and the constant threat of being punctured by a rock the size of a football. To withstand this biblical abuse, earth-mover tires are built like battleships. The amount of rubber used in a single one could probably make thousands of car tires. Beneath the surface, the carcass is a fortress of thick, high-tensile steel cables, layered to create a structure of immense strength. The tread itself can be a foot deep, made from specially formulated rubber compounds that are designed to resist cuts, chips, and tearing. Some designs even incorporate a chain mail-like net that wraps around the tire to provide an extra layer of protection against the sharpest rocks. The tread patterns on these monsters are not for channeling water. They are all about two things: grip and protection. The patterns feature massive, chunky blocks called lugs, separated by deep voids. These lugs bite into loose surfaces like dirt and gravel to provide the traction needed to haul hundreds of tons up a steep gradient. The sheer thickness of the tread also helps to dissipate the incredible heat that builds up from the friction and flexing under such enormous loads. These tires are not just components. They are monumental feats of material science and engineering, designed to move mountains. Specialist tires are engineered for one job, like tractor tires with V-shaped lugs for grip and self-cleaning in muddy fields. Their low pressure spreads weight, protecting crops. Racing tires, on the other hand, are built for maximum grip, using soft rubber that heats up for extreme adhesion, lasting only a few dozen miles. Slicks maximize contact on dry tracks but become useless in rain, requiring treaded wet tires. Each tire is a study in purpose. Farm tires float over soil, racing tires stick to tarmac. Design is about excelling at one thing, sacrificing all else. Whether in a field or on a racetrack, tires are precision tools for their environment. The sidewall of a tire is packed with coded information: size, load, speed rating, and more. For example, 205/55 R1691V means 205 mm wide, 55% aspect ratio, radial construction, 16-inch rim, 615 kilograms load, and 149 miles per hour speed. The load index and speed rating are crucial for safety. Never go below your car's requirements. Manufacture date is a 4-digit code. Tires age even if unused. Symbols show if it's a winter tire or has run-flat tech. The sidewall is a data sheet, not just branding. Learn the code and you'll know exactly what your tires can do. It's the tire's way of talking to you. Tire making starts with a blend of natural and synthetic rubber, each bringing flexibility or engineered properties. Carbon black, a fine powder, is added for strength and durability. making tires black for engineering, not style. Sulfur, antioxidants, and oils join the mix for resilience and workability. Up to 30 ingredients are measured with precision. The result? A custom rubber blend tailored for each part of the tire. It's a technical recipe, not just melted rubber in a mold. Every ingredient has a purpose in the final product. Ingredients are dumped into a Banbury mixer. Giant blades churn and heat the rubber blend. The hot, uniform compound is milled into thick sheets by massive rollers, cooling and strengthening it. Different recipes are made for tread, sidewalls, and internal layers. Each batch is tailored for its job, hard for tread, flexible for sidewalls. The result? Sheets of specialized rubber ready for assembly. It's industrial baking, but for tires. The next stop? The assembly line. Tire assembly starts on a rotating drum, layer by layer from the inside out. The inner liner holds air, carcass plies give strength, and steel beads anchor the tire to the rim. Sidewalls protect and display information. Steel belts under the tread add stability and grip. The final layer is the tread itself. The result? A green tire, fully assembled but uncured. It's a high-tech layer cake ready for transformation. Next comes the crucial curing process. The green tire enters a mold where heat and pressure trigger vulcanization. Sulfur cross-links the rubber molecules, giving strength and elasticity. The mold imprints the tread and sidewall markings. Timing and temperature are critical. Too little or too much ruins the tire. After curing, the tire emerges tough, bouncy, and ready for the road. This is the final transformation from raw materials to a finished product. The tire's journey is complete. Just because the tire has emerged from the curing press looking perfect, doesn't mean it's ready for the road. The final stage of the manufacturing journey is perhaps the most important for your safety inspection. Every single tire that comes off the production line goes through a rigorous series of quality control checks to ensure it meets exacting standards. There is no room for error here. A single flaw could lead to a catastrophic failure at high speed, so the inspection process is relentless and thorough, combining the sharp eyes of trained inspectors with the precision of sophisticated machinery. The first step is a visual inspection. A trained expert carefully examines every inch of the newly minted tire both inside and out. They are looking for any visual blemish, no matter how small. This could be a tiny air bubble trapped in the rubber, a slight imperfection in the sidewall lettering, or any sign that the layers have not bonded together perfectly. They run their hands over the surface, feeling for any lumps or distortions that might indicate an internal problem. Any tire that shows even the slightest hint of a flaw is immediately rejected and sent to be analyzed and then usually shredded. After passing the human eye test, the tire moves on to the machines. It is placed on a test wheel and inflated to its proper pressure. Special sensors then check the tire for uniformity and balance. They measure for any tiny variations in the stiffness of the sidewall or any slight wobble, known as runout, as the tire spins at high speed. These are imperfections that would be invisible to the naked eye, but could cause vibrations and an uncomfortable ride when fitted to a car. A small colored dot is often painted on the sidewall to indicate the lightest point of the tire, helping the fitter to balance it perfectly on the wheel rim. Finally, a random selection of tires are pulled from the production line for even more extreme destructive testing. They might be X-rayed to search for any internal voids or structural problems. Some are cut into sections to check the dimensions and bonding of the different layers. Others are put onto test rigs that run them against abrasive surfaces until they are destroyed, to verify their durability and lifespan. Only when a batch has passed all these checks is it finally cleared for shipping. The journey from a pile of raw ingredients to a finished road-ready tire is complete. We've made the tires, now let's see what they go on. Forget car factories. Here we build giants, excavators, bulldozers, and dump trucks. The scale is immense, the machines are complex, and the engineering is precise. This is where raw strength meets precision, real engineering shaping the world. Every great machine starts with a great skeleton. For a bulldozer or excavator, that's the chassis, an immense, over-engineered steel frame built to withstand unimaginable forces, shocks, and weight. Welded, heat-treated, and painted for protection, this rugged foundation is designed to be battered and bruised, ready for a lifetime of hard work. With its skeleton now built and protected, the machine is ready for its heart. Now for the best bit, the power, the soul of the machine, the engine. Monstrous turbocharged diesel engines, hearts that move mountains. Carefully lifted and installed, connected with precision. Finally, the moment of truth. The beast roars to life. The machine now has a heartbeat. Hydraulics are the muscles, electronics the brain, pumps pressurize oil, powering cylinders that move with force. Sensors and computers connect everything, letting the operator control the machine with precision. It's this blend of strength and intelligence that makes modern heavy machinery so powerful and precise. The machine is almost complete, chassis, engine, and hydraulics in place. But it needs its tools. The boom, arm, and bucket are attached with massive steel pins and hydraulic cylinders. For bulldozers and dump trucks, it's the blade or bed. With final touches, it's ready to roll out, powerful and complete. Big machines need the right connection to the ground, tires or tracks. Tires offer speed on hard surfaces, but tracks spread weight, letting machines float over mud and soft ground. It's a classic engineering choice, speed and mobility, or all-terrain grip. The decision shapes what the machine can do and where it can go. Wheels are the clear choice for speed, roadworthiness, and protecting surfaces. Tracks excel in mud, but are slow, noisy, and damage roads. That's why you see wheeled machines like cranes, tractors, and backhoe loaders on roads and in cities. They're faster, gentler, and easier to maintain. For most jobs, wheels win, unless it's all about mud. Now for the other side of the argument, the heavyweights, the unstoppable force, the track. If a machine's job is to work exclusively in the worst conditions imaginable, where the ground is soft, uneven, and treacherous, then there is no substitute for tracks. A bulldozer's entire purpose in life is to push massive amounts of earth with brutal force. To do that, it needs two things: incredible traction and very low ground pressure. Wheels would just spin uselessly, and the machine would dig itself into a hole. The long, wide tracks provide a phenomenal amount of grip, biting into the surface and allowing the machine to apply its full engine power without slipping. This is what we call tractive effort. It's the raw pushing or pulling power a machine can generate before its feet start to slip. Because of their huge contact area and the way the metal grousers, the raised bars on the track pads, dig into the ground, a tracked vehicle has vastly superior tractive effort compared to a wheeled one of the same weight and power. This allows a bulldozer to push a mountain of dirt or a tracked excavator to climb a steep, muddy embankment that a wheeled machine wouldn't even attempt to look at. They can go anywhere and do anything. The low ground pressure we talked about is not just for mud, it also gives the machine incredible stability. Because the weight is spread over such a large and stable base, a tracked excavator can sit on the edge of a trench or on a steep slope and operate its long, heavy arm with confidence. A wheeled machine in the same position would be much more likely to tip over. This stability allows tracked machines to work safely in places that are simply off-limits to their wheeled counterparts. They provide a solid, dependable platform, no matter how dreadful the terrain gets. Ultimately, tracks are for the specialists. They are for the machines that have one job to do, and they do it in the toughest places on Earth. They sacrifice speed, mechanical simplicity, and on-road manners for pure, unadulterated off-road dominance. For digging foundations, landscaping, mining, and demolition, where the ground is a chaotic mess, tracks are king. They are the heavy-duty hiking boots of the machinery world, while wheels are the running shoes. You wouldn't wear running shoes to climb Everest, and you wouldn't wear hiking boots to run a marathon. It's about having the right tool for the job. Tires may look simple, but before they reach your car they're tortured in labs and on test tracks. Engineers push them to the limit, spinning, pounding, soaking, and sliding, so you can trust them in any condition. Only after surviving this gauntlet are tires approved for your safety. Testing a bulldozer isn't just about starting the engine. These machines face brutal endurance tests, steep hills, deep mud, and relentless stress. Operators try to brake them, while engineers monitor every strain and flex. Only after surviving months of calculated abuse do bulldozers earn their reputation as the toughest machines on Earth. The story of how we move and build our world is one of rubber, steel, and ingenuity. From tires on family cars to titanic machines shaping cities, these inventions have shrunk the planet and enabled global trade. Wheels or tracks, each is the right tool for the job, making the impossible possible every day. The unseen revolution of tires and engines changed everything, giving us freedom of movement, powering cities, and building our world. Now, smarter, cleaner, and more automated machines are here. The journey of tires and tracks isn't over, it's just getting started.